The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ydcc.edu and I'll respond as soon as I can. Alrighty, so today we're going to start chapter 10. We're going to take a look at section 10.1. And so let's get started. 10.1. All right. Let's briefly go back to chapter 6, where we looked at solving second degree equations by factoring. And let's say we had the following problem. X squared minus 16 equals 0. So here we have a second degree equation or a quadratic equation in standard form, set equal to 0, and the left side of the equation is in descending powers. This is the difference of two squares, so we can factor it into x plus 4 times x minus 4 equals 0. Then we take each factor that contains a variable and set it equal to 0. And then we go back and we solve each of these first degree equations. We get x is -4. Here, adding 4 to both sides, we get x is +4. So we get two solutions to this second degree equation. Any questions about this? All right, let's take another look at this problem and consider a different way to do the problem. What we're going to do, we're going to put the equation in a form where on one side of the equation we have a perfect square that contains the variable, and on the other side of the equation we'll have a constant. So to do that, in this case, I add 16 to both sides of the equation, and I get x squared equals 16. Now what I'm going, hang on here. What I'm going to do next is to take the square root of both sides of the equation. So I get x equals 4. However, there's a problem because we already showed that there were two solutions. X is -4 and x is +4. So in fact, when we take the square root of both sides of the equation, on the constant side, we're going to add the little notation plus or minus. This is a way of saying x equals -4 and x equals 4, but as a package deal. So we say x equals plus or minus 4. Okay, any questions about that? All right, let's take a look at another example. Here we have t squared minus 11 equals 0. So we're going to add 11 to both sides of the equation. T squared equals 11. So now I have a perfect square on the left side and a constant on the right. I'll take the square root of both sides, including the plus or minus. So I get t equals plus or minus the square root of 11. I can't do anything to simplify the square root of 11. It's irrational. So there are my two answers. Again, the same thing as saying t equals negative the square root of 11 and positive the square root of 11. Okay, let's say I've got u squared minus 24 equals 0. So I'm going to add 24 to both sides of the equation and I get u squared equals 24. Then I'll take the square root of both sides of the equation, and I get u equals plus or minus the square root of 24. However, 24 is 4 times 6, so the square root of 24 is the square root of 4 times 6 is 2 square roots of 6. So I will simplify it further and say u equals plus or minus 2 square roots of 6. Now, this whole process of taking the square root of both sides is called the square root property. And again, we have to get it into, let's see, I'll put a constant. and we'll say variable inside. So we have a perfect square on the left side of the equation that contains the variable and a constant on the right side of the equation. Then we take the square root of both sides and we include a plus or minus to the constant side of the equation. Okay, let's see here. Let's take a look at one more example. I have 3x squared minus 16 equals 0. So to solve this equation, first of all, I'm going to add 16 to both sides of the equation, which gives me 3x squared equals 16. Then I'm going to divide both sides by 3, so I get x squared equals 16 thirds. Now it's in that form. A perfect square containing the variable equals a constant. We'll take the square root of both sides, and at that point, we'll include the plus or minus. So this gives me x equals plus or minus the square root of 16 over 3. However, we've learned how to simplify radicals that are fractions by rationalizing the denominator. So this becomes plus or minus the square root of 13 over the square root of 3. I'll multiply that by the square root of 3 over the square root of 3. And I get x is plus or minus the square root of 39 over 3.
How did you get 13 over 3?
Because I screwed up.
Okay, good.
I don't know what it is with me. I just, yeah. I don't know. So this is going to be what? 4 square roots of 3 because the square root of 16. That's why you need to be here to keep me honest. Okay. Yes. I shouldn't get a job as a counterfeiter. I do a lousy job of copying from one thing to the next. Okay. But here again, so we simplified, rationalized the denominator, all that stuff we've learned in the past comes forward with us here. All right. Let's see here. Let's take a look at some more examples of this. Let's say we've got x minus 1 squared equals 4. This is already in that form. A perfect square with a variable inside equals a constant. So we'll take the square root of both sides. So we get x minus 1 equals plus or minus 2, the square root of 4. But I haven't solved for x yet. I need to add 1 to both sides of the equation. So I get x equals 1 plus or minus 2, which means x equals 1 plus 2, which is 3, and x equals 1 minus 2, which is negative 1. So x equals negative 1, comma 3, and there are your solutions. Be careful in WebAssign not to put parentheses around it because then it thinks you're putting in an ordered pair, I believe. So just be careful with that. Make sure to follow the directions it gives you. Okay, let's see here. Now, also in WebAssign, it doesn't allow you to put the plus or minus into the little boxes there. It may have some answers where it's multiple choice, or some of them have that, but the notation, basically it might say x equals, you'd put in this, and then that. Wait a second here. What happened to the 4? I thought I had a 4 there.
You did it circled above. You didn't add it to the bottom.
Oh, okay. My bad. Thank you. Thank you. Yeah, so this was the
So on, can we talk about slide 17 after you're done?
talk about what?
Can we talk about slide 17 after you're done with this one?
Slide 17. Yes. Well, all I wanted to say back here was you can't use this notation. You can't insert it into WebAssign. You have to use separate the plus and the minus. Okay. All right. Yes.
Okay, so on this one, we go x minus 1 equals plus or minus 2. But since we're not done with the equation fully yet, we have to add 1 to each side. Would we, so we don't add it to the 2 and then add plus or minus at the end?
No, we don't,
So we
because
will always end up with the 2, the 3, and the -1.
yeah, you're gonna put this in front of the plus or minus 2.
Okay,
So, because basically what you've got is you've got that and you've got that. In other words, if you split those up, that's your plus or minus. So you're adding 1, so you're going to get 3. You're adding 1, you're going to get -1. So what you want to do, and let me erase this. Let's see here. Probably would have been faster just to start over. So when you've got that, okay, what you don't want to do is add the 1 out here, because then some people confuse that with that. And
right.
plus or minus does not apply to the 1. It only applies to the 2. So you're much safer to put it in the front. And
Okay,
then,
that makes sense.
okay, and then take it all the way out. Yeah. As long as these are rational numbers, you don't have any square roots, go ahead and write them out completely like this. Okay. We good so far?
Yeah.
Okay. Now, let's see here. So we're going to look at a problem, x squared plus 24x. It says complete the square and factor the resulting perfect square trinomial. Okay. And what we need to do, we're going to take this number. Okay. So the coefficient of x, we're going to cut it in half. And then we're going to square it. Okay. Now, if I take that 144 and include it there, this is a perfect square trinomial, which factors into that, which then could be written like that. So what we're doing here is we're completing the square in terms of we're taking a given expression, manipulating it to create a perfect square trinomial, which can then be written as a quantity squared that contains a variable. So that's getting it ready to use that square root property on it. Okay. Now, let me go through that a few more times to get you to see the pattern. Let's say I've got y squared minus 18y. I take the coefficient of y. Okay. I cut it in half. I square it. And then I attach that constant to the end. What I've now done is created a perfect square trinomial, and the factors are going to include this number that's in here, which, whoops, not x, y. So I could then write it as y minus 9, the quantity squared, which if I FOIL it back together would give me this. So I'm taking this, figuring out what to add to it or subtract from it in order to create a perfect square. Okay. Let's take a look at some more of those. A squared minus 7a. So I'm going to take the coefficient of the a, -7, divide it by 2, which is -7/2, square it, which is 49/4, and add that out at the end. I now have a perfect square trinomial, which I can write like that. Any questions about this process? Again, notice that this number inside of here is what goes there and there. Okay. let's do another one that's a bit more complicated. Make sure you've got this idea, x squared plus 2/3 x. Okay, so the coefficient of x is 2/3. We're going to divide that by 2, which is 2/3 times the reciprocal 1/2, which reduces down to 1/3. Then I take the 1/3 and square it, which is 1/9, and I add that to create a trinomial, which, when factored, ends up being a perfect square. Again, notice this number here is what goes there and there. Notice here it was negative, so it's negative. Here it's positive, so it's positive. Are you okay with this process?
Yes.
Okay. Now, we're going to take an equation and we're going to use completing the square to solve this equation. And then when necessary, we'll approximate each solution to the nearest hundredth. In other words, if it doesn't come out nice numbers, if they're irrational. All right, now I've given you kind of the last few steps. Now we're going to give you the whole process. The first thing we need to do is to get rid, actually, let me double check here because I think they do it. There's 2 different ways you can do. Yeah, okay. The first 2 steps, it doesn't matter which order it's in, but I'll do it the way the book does. If the coefficient of the variable squared term is something other than a 1, you need to divide it out by dividing every term on both sides by that. And we'll get there eventually. But in this case, it's a 1, so I don't need to do the first step, which is to get the leading coefficient to be a 1. It already is. Okay, the next step is to move the constant to the right side of the equation, or I should just say the other side. Okay, now, if you look at the left side of the equation, you'll see that it looks very much like the last few problems we did. We have a squared term and a variable to the first power term. Okay, so I'm going to take the coefficient of x. I'm going to divide it by 2. I'm going to square it. And then I'm going to add it to the left. But now that we're actually dealing with an equation, if we add 4 to the left side of the equation, we must also add 4 to the right side of the equation. So now what I have is x squared minus 4x plus 4 equals 6. But on the left side of the equation, I have a perfect square trinomial. X minus 2 times x minus 2, which could be written as x minus 2 the quantity squared. Okay. So now I have a perfect square on the left side of the equation containing a variable equal to a constant on the right side of the equation. So my next step is going to be to take the square root of both sides of the equation. Don't forget the plus or minus. So I get x minus 2 equals plus or minus the square root of 6. Okay. Then I'm going to add 2 to both sides of the equation. So I get x equals 2 plus or minus the square root of 6. So x equals 2 plus the square root of 6, x equals 2 minus the square root of 6. Okay. Now, so there's my 2 answers. And then it said approximate each solution to the nearest hundredth. So I get, let's see here, 2 plus the square root of 6. And I get 4.449489, et cetera, et cetera. So to the nearest hundredth, which would be here, the 9 would round up, so it'd be 4.45. Now, The minus is going to be negative 0.449489, et cetera, et cetera. So again, I'm going to round up and get negative 0.45. So here are my exact solutions and the approximate solutions to the nearest 100. Any questions about that example? Okay, let's see here. How are we doing? Yeah, let's do another one that has a leading coefficient of 1. So we've got t squared plus 14t minus 7 equals 0. My leading coefficient is a 1, so I don't need to do anything there. I'm going to add 7 to both sides of the equation. Notice I leave a space here. That's because I'm going to be a space right in here because I'm going to be adding a number to both sides of the equation here in a minute. So I'm going to take the coefficient of t, which is 14, divide it by 2, which is 7, square it, which is 49. I'm going to add 49 to both sides of the equation. On the left side of the equation, I now have a perfect square trinomial. On the right side, I have 56. So I've got t plus 7, the quantity squared, equals 56. So what have I done? I've created a perfect square trinomial on one side of the equation and a constant on the right side of the equation, the other side. Okay, so now take the square root of both sides. So t plus 7 equals plus or minus, the square root of 56. I'm going to subtract 7 from both sides. So t equals negative 7 plus or minus the square root of 56. However, I can take the square root of 56, and that is, let's see, that's 4 times 14. And I could have factored it down further, but I'm just breaking it down into a square in the leftover. So that's going to be 2 square roots of 14. Okay, so the square root of 56 is 2 square roots of 14. Any questions there? All right, so t equals negative 7 plus 2 square roots of 14. T equals negative 7 minus 2 square roots of 14. And then again, calculator on the first one, negative 7 plus 2 times the square root of 14. And I'm getting 0.483, etc. Rounding to the nearest hundredth, the 3 would round down, so you'd get 0.48. And then the negative, negative 14.483, etc. Again, the 3 rounds down, negative 14.48. And so let me see here. Where did I get that from? So your solutions, here are the exact solutions, and here are the decimal approximations. Okay. Any questions there? All right, let's head off into the deep end. Worst case scenarios. So in this case, our leading coefficient is not a 1, okay? So my first move is to divide each term on both sides of the equation by the coefficient of the squared variable, since it's not a 1. This gives me x squared minus 2x plus 1/6 equals 0, okay? The next step is, as before, to move the constant term. Again, I'm going to leave a space here. Okay. So now I take the coefficient of x, divide it by 2, square the results, and add that to both sides of the equation. On the left side, I now have a perfect square trinomial. On the right side, let's see, -1/6 plus 1 would be -1/6 plus what? We'd have to multiply the 1 by 6/6. So we'd end up with 5/6. Okay. You all right with that? Now I'm ready to apply the square root property. Okay. And I think what I'm going to do is I'm going to go to the next page. So let me recopy that. X minus 1 squared equals 5/6. We'll go back in case you need anything here for a minute. Okay. So now I'm going to take the square root of both sides. I'm going to add 1 to both sides. I'm going to simplify my radical. By multiplying by the square root of 6 over the square root of 6. And let's see. Now, this is a correct answer, but just to get you used to what you may encounter in the future, what math people like to have you do is to write it as a single fraction. And to do that, you'd say, well, the 1 is 1/1. My common denominator is a 6. So I'm going to multiply this over 6, and I get x equals 6 plus or minus the square root of 30 all over 6. So if we weren't using WebAssign, if we were in the classroom and you were looking at the answer in the back of the book, this is what they would have. Okay. It's no different from that. They're both correct, but I'm just telling you this notation, what they do is they write it as a single fraction. Okay. Now, if I'm going to split these up into separate answers, I would get to that point. Then I'd plug these into my calculator. Oh. But the thing you've got to be careful of is you've got to quantify the numerator, and you also might have to quantify the amount in the radical, okay? Just depending on what your calculator does. So for instance, on my calculator, this is how I'm going to put it in the calculator. I'm going to go parentheses 6 plus the square root, and then it's going to give me another parenthesis, which I'm going to put 30 in there. Then I'm going to close up that set, and then I'm going to close up the whole thing. Divided by 6 equals. So I've got the blue ones are around the radicand, saying that's what's inside the radical, and the red ones are around what's the entire numerator, because that entire numerator needs to be divided by 6. If you're getting the wrong answer, you're probably not putting in the red parentheses. Not that they'll be red on your calculator, but anyway. Okay. So I've got 30. I close that up. I close up the whole thing divided by 6, and I get 1.912, which the 2 is going to round down, so 1.91. Okay. And then the minus. So on this bottom one, I'm going to have 6 minus the square root of 30. And again, there's going to be a set of parentheses there and a set of parentheses around the whole thing, divided by 6. And I get 0.087. The 7 would round up, so you'd get 0.09. So here are the exact answers, and here are the decimal approximations to the nearest hundredth. Okay. And again, WebAssign should accept these instead of those. So you don't have to do this, but I'm just telling you, you're going to run into that notation sooner or later if you go on in your math career, which I assume you will be. Okay. I know it's like the easy part is getting to the perfect square, because you got all this stuff you got to clean up and everything. Let's take a look at another example. Are there any questions on this one? Okay. Let's see here. How are we doing for time? 2x squared minus 8x plus 5 equals 0. So my leading coefficient is not a 1, so I'm going to divide everybody, each term, by whatever it is, in this case a 2. I get x squared minus 4x plus 5 halves equals 0. Then I move the constant over, and I get x squared minus 4x equals negative 5 halves. Let's cancel out. I take the coefficient of x, I cut it in half, I square the results, and I add the results to both sides of the equation. On the left side, I have x minus 2 times x minus 2, which is x minus 2, the quantity squared. On the right side, let's see, my common denominator would be 2. So I'm going to multiply the 4 over 1 by 2 over 2 to get 8 over 2. And negative 5 halves minus 8 halves is positive 3 halves. Okay. So now I've got my perfect square. I'm going to take that and copy that on the next page. Hang on here a second. Okay. So we're going to have x minus 2 squared equals 3 halves. Take the square root of both sides, including the plus or minus. So I get x minus 2 equals plus or minus the square root of 3 over 2. I'm going to add 2 to both sides of the equation. X equals 2 plus or minus the square root of 3 over 2. I'm going to rationalize the denominator of the radical by multiplying by the square root of 2 over the square root of 2. So x is 2 plus or minus the square root of 6 over 2. And again, that's a correct set of answers. But like I say, what you'll encounter in the future is they'll take this and they'll say, we need it to look like, oops, that. So let's go back up here and multiply by 2 over 2. So then we get 4 plus or minus the square root of 6 all over 2, which then becomes x equals 4 plus the square root of 6 over 2, x equals 4 minus the square root of 6 over 2. And let's see here, in a second. We're going to go to the calculator. So again, we're going to have parentheses 4 plus the square root of 6, close parentheses, divided by 2. Okay, so parentheses 4 plus the square root of 6, close it up, close the whole thing up, divided by 2. And we're getting 3.224. So we get 3.22. And then the minus 4 plus, oops, not 4 plus, 4 minus the square root of 6 divided by 2. And hang on a second here. I've got 0.775, so that's going to be 0.78. So here are the exact answers as well as there, and then here are the decimal approximations. So again, you should be able to enter this or this. If you're going to do this top one, you'd have to write the 2 plus and then the 2 minus. Again, WebAssign, as far as I know, doesn't allow you to enter that plus or minus notation. Okay, how are we doing? Let's see here. Let's take a look at how about this one. 5x minus 2 squared equals 64. Solve each equation, approximate the solutions to the nearest hundredth when appropriate. This is already in the form that we started out the whole class in, right? So I could go ahead and take the square root of both sides. And I get 5x minus 2 equals plus or minus 8. Then I would add 2 to both sides. 5x equals 2 plus or minus 8. And then I would divide both sides by 5. So x equals 2 plus or minus 8 over 5. 2 plus or minus 8 over 5, which means x equals 2 plus 8 over 5, which is 10 over 5, which is 2. X equals 2 minus 8 over 5, which is negative 6/5, which again, I guess is still negative 6/5. So let's do this. Let's get rid of that. Okay. All right, so completing the square. You've got a 3-day weekend coming up. I'll be back this afternoon at 1:15 with an office hour, but there's no classes on Monday. So I will be back again on Tuesday at 11:30. I will most likely not be available this weekend. So if you have some desperate questions or things, I probably won't get in touch with you till Monday. Anyway, have a great weekend. Be safe. And with that, I shall stop the recording.